it is generally not recommended to double up wires within a meter can enclosure. Several critical factors come into play, primarily concerning safety, code compliance, and the approved usage of electrical equipment. A meter can, also known as a meter socket or meter base, is specifically designed and listed to accommodate a defined number of conductors and a specific range of conductor sizes. The internal components, including the terminals and busbars, are engineered to provide secure connections and adequate heat dissipation for the intended load. Doubling up wires, which involves connecting two conductors to a single terminal designed for only one, introduces several potential problems. Firstly, the terminal may not be designed to accommodate the physical size of two conductors. Attempting to force two conductors into a terminal designed for one can result in a loose or inadequate connection. This loose connection increases the electrical resistance at that point, leading to heat generation. Over time, this heat can degrade the insulation of the conductors, potentially leading to a short circuit or an electrical fire. Secondly, even if the two conductors physically fit within the terminal, the increased current density can exceed the terminal's design capacity. Terminals are rated for a specific ampacity, which is the maximum amount of electrical current they can safely carry. When two conductors are connected to a single terminal, the current flowing through that terminal is effectively doubled, potentially overloading the terminal and causing it to overheat. This overheating can damage the terminal, the conductors, and the surrounding enclosure, creating a fire hazard. Thirdly, doubling up wires can violate the National Electrical Code or NEC and other local electrical codes. The NEC provides detailed requirements for the proper installation of electrical equipment, including meter cans. Section 110.3 B of the NEC requires that all equipment be installed and used in accordance with its listing and labeling. This means that the meter can must be used only for the purpose for which it was designed and listed. If the meter can is not listed for multiple conductors in a single terminal, then doubling up wires would be a violation of this section. Furthermore, Section 310.10 H addresses the issue of terminal compatibility. It states that conductors must be terminated in a manner that ensures a reliable electrical connection. Doubling up wires can compromise the reliability of the connection, as it may not provide the same level of mechanical or electrical contact as a properly installed single conductor. From a practical standpoint, if an additional 100 amp service is required for a garage, the best and safest approach is to install a separate meter can dedicated to that service. This ensures that each service has its own properly sized and rated connections and that the installation is in compliance with all applicable codes. When installing a new meter can, several factors must be considered. Firstly, the size of the meter can must be appropriate for the service size. The meter can must be rated to handle the maximum current that will flow through it. For a 100 amp service, a meter can rated for at least 100 amps would be required. Secondly, the conductors used to connect the meter can to the service panel must be properly sized. The size of the conductors must be based on the ampacity of the service and the applicable NEC tables. For a 100 amp service, conductors such as number 3 copper or number 1 aluminum would typically be used, but specific sizing depends on factors like insulation type and ambient temperature. Refer to NEC Table 310.16 for appropriate conductor ampacities. Thirdly, the overcurrent protection for the service must be properly sized. The overcurrent protection device, such as a circuit breaker or fuse, must be rated to protect the conductors and the equipment connected to the service. For a 100 amp service, a 100 amp circuit breaker or fuse would be required. Fourthly, the meter can must be properly grounded. Grounding is essential for electrical safety as it provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock hazards. The meter can must be grounded to a grounding electrode system, which typically consists of a ground rod or a connection to the metal water pipe system. The grounding conductor must be properly sized based on the size of the service conductors, and the grounding connections must be made in accordance with the NEC requirements. The specific grounding requirements can be found in NEC Article 250. In summary, doubling up wires in a meter can is not recommended due to the potential for overheating, fire hazards, and code violations. The safest and most code-compliant approach is to install a separate meter can for each service. When installing a new meter can, ensure that the meter can, conductors, and overcurrent protection are properly sized and that the meter can is properly grounded. Always consult with a qualified electrician to ensure that the electrical installation is safe and in compliance with all applicable codes and regulations. When considering the existing 2/0 conductor feeding the 100 amp service, it's important to understand why this larger conductor size might be in place. There could be several reasons, including voltage drop considerations, future load expansion plans, or simply an earlier installation practice. While 2/0 copper conductors are typically rated for well above 100 amps, their use in this scenario does not automatically permit doubling up for an additional service. The critical factor remains the listing and design of the meter can terminals. Even with an oversized feeder, the connection point at the meter can is the limiting factor. NEC section 310.15 governs conductor ampacity, and while it allows for ampacity adjustments based on factors like ambient temperature and the number of current carrying conductors in a raceway, it does not override the equipment's listing and labeling requirements as stipulated in NEC section 110.3. Therefore, the presence of a larger conductor does not justify violating the terminal limitations of the meter can. If the goal is to add a 100 amp service to a garage, a proper approach involves evaluating the overall load on the existing service and determining if it can handle the additional load. This load calculation should follow the guidelines outlined in NEC Article 220. If the existing service has sufficient capacity, a subpanel can be installed in the house, fed from the main 100 amp panel. From this subpanel, a feeder can be run to the garage. This approach avoids any modifications to the meter can and ensures that all connections are made within listed and approved equipment. Alternatively, if the existing service does not have sufficient capacity, a service upgrade may be necessary. This would involve replacing the existing meter can, service panel, and service conductors with larger ones to accommodate the increased load. A qualified electrician can perform a load calculation to determine the appropriate size for the new service components. The NEC also addresses the installation of multiple services to a building in section 230.2. It generally allows for one service per building, but exceptions exist for situations such as large capacity requirements or different voltage systems. If installing a completely separate service for the garage, it's important to ensure compliance with these requirements. Furthermore, when running conductors to the garage, proper wiring methods must be followed. Conductors must be protected from physical damage and installed in accordance with the NEC. Depending on the specific installation, this may involve using conduit, cable trays, or other approved wiring methods. Grounding and bonding are also critical aspects of the garage electrical system. A grounding electrode system must be established at the garage, and all metal enclosures and equipment must be properly bonded to the system. This ensures that any fault current will have a safe path back to the source, tripping the overcurrent protection device and preventing electrical shock hazards. In conclusion, while the idea of doubling up wires in a meter can may seem like a convenient way to save space and avoid installing a new meter can, it is generally not a safe or code-compliant practice. The potential for overheating, fire hazards, and code violations outweighs any perceived benefits. The best approach is to install a separate meter can for each service or to upgrade the existing service if necessary. Always consult with a qualified electrician to ensure that the electrical installation is safe and in compliance with all applicable codes and regulations. They can assess the specific situation, perform load calculations, and recommend the most appropriate solution. Remember that electrical safety is paramount, and any electrical work should be performed by a qualified professional. Code compliance is not just a matter of following the rules, it's about ensuring the safety and reliability of the electrical system for yourself and others. In addition to the safety and code compliance considerations, it's important to consider the long-term reliability and maintainability of the electrical system. Doubling up wires can create a situation that is difficult to troubleshoot and maintain. If a problem arises, it can be challenging to identify the source of the problem and to make repairs. Installing a separate meterkin for each service, on the other hand, provides a clear and organized electrical system that is easier to troubleshoot and maintain. Each service has its own dedicated connections and overcurrent protection, making it easier to isolate and repair any problems that may arise. Furthermore, installing a separate meterkin allows for future expansion of the electrical system. If additional load is required in the future, it can be easily added to the separate service without having to make any modifications to the existing service. This provides flexibility and scalability for the electrical system. When making any changes to an electrical system, it's important to obtain the necessary permits and inspections from the local electrical authorities. This ensures that the work is performed in accordance with the applicable codes and regulations and that the electrical system is safe and reliable. A qualified electrician can assist with obtaining the necessary permits and inspections and can ensure that the work is performed to the required standards. Remember that electrical work can be dangerous, and it's always best to leave it to the professionals. Qualified electricians have the training, experience, and equipment necessary to perform electrical work safely and correctly. They can identify potential hazards and take the necessary precautions to prevent accidents. They also have the knowledge and expertise to ensure that the electrical system is installed in accordance with the applicable codes and regulations. By hiring a qualified electrician, you can have peace of mind knowing that the electrical work is being performed safely and correctly and that the electrical system is reliable and compliant. In summary, while the temptation to save space and money by doubling up wires in a meterkin may be strong, it's important to resist that temptation and to do the job right. The potential risks and liabilities associated with doubling up wires are simply not worth it. The best approach is to install a separate meterkin for each service or to upgrade the existing service if necessary. Always consult with a qualified electrician to ensure that the electrical installation is safe, code compliant, reliable, and maintainable.